Okay, hi everyone. This is my first ever live stream. I know that a lot of year 11s and year 12s have got their mock exams coming up, or at least they've got quite significant assessment points in the next few weeks. So I thought I'd have an experimental session of going live just to give some extra revision hints and tips for year 11 and year 12 and 13. So this first one, starting now at 1 o'clock, is for year 11. Okay. And what I thought I'd do is I'm going to work through some of like the grade 9 and grade 8 questions from a really recent mock paper. So this is from Edexcel mock set 7. It's not the actual most up to date, but it's quite a recent mock set so it'll give us a good feel for the current kind of questions that exam boards are asking. And what I'm going to do is, so this is the paper, and we're going to work from the end of the paper through to the beginning. So we're going to start off at the very last question, a kind of grade 9 question. Okay. And I'll just go through these and hopefully you will find this to be quite useful. Right, so let's have a look. So this first question, now this one, by the way, is, those of you who are in year 11 and considering whether or not you should do A-level, this kind of question is very much like an A-level kind of question. So this could be exactly an A-level coordinate geometry question from year 12, actually. So it says C is the circle with the equation x squared add y squared is equal to 80. And P is a point on C. The coordinates of P are minus 4k. We don't know what k is, but we know that k is less than 0. So what that means is it means that it must be in this quadrant here, okay? Because we know that we've got the x is minus 4, and we know that the k is less than 0. So it's got to be in this quadrant here, the point P. The first thing to notice as well is that our equation is x squared add y squared is equal to r squared is the equation of a circle. Okay, and they tell us that here we've got x squared add y squared is equal to 80. So that means that r squared is equal to 80. So if the radius squared is equal to 80, then that means that the radius is equal to root 80. Now for GCSE, all of the circles are going to be centered on the origin. So I've drawn a rather badly drawn circle there, but it has its center on the origin and it has a radius of root 80. And we've got this tangent to the circle here at the point P. And the object of this question is to try and find an equation of the tangent to the circle at the point P. So let's think about what we're going to do. So step one is, first of all, we could really do with knowing what the y value is for k. Okay, so our first step is we're going to substitute in the point for k into the equation of the circle. Okay, so let's sub that in. So when we sub that in, we get that our x is minus 4. K, we don't know what that is yet. So we're just subbing in the x and y into the equation of the circle because the point P is a point on the equation of the circle. So it satisfies that equation. Well, when we sub that in, we get minus 4 squared is going to give us 16. So we're going to have 16 add k squared is 80. So therefore k squared is equal to 80, take away 16. And then we're just going to have that gives us 64. So we square root that. Root 64 gives us plus or minus 8. So the two potential values of k is k could be plus 8 or k could be minus 8. Okay. So we don't know which one it's going to be. We do actually, because the question tells us that the k is going to be negative. So it's not going to be the positive one. It's going to be the minus 8. So we found out that k is minus 8. And if anyone has any questions, by the way, if you're going through, just put them in the comments and I'll endeavor to answer your questions as we go through. So we found out that k is minus 8. So we now know the coordinate of P is minus 4 minus 8. Perfect. So that's step one. Now, step two in this kind of question, and I know that in year 11, students find this like really confusing. We got to find now the gradient of the radius. Okay. So the gradient of the radius is going to be change in y over change in x. So we take our y coordinate, so minus 8, we're going to take away 0. So that's our change in y over our change in x, which is going to be minus 4 minus 0. So that's minus 8 over minus 4, which is 2. So this radius has a gradient of 2. Now, the next step is the tangent. A tangent makes a 90-degree angle with a radius. So we know that this angle here has to be 90 degrees. And what that means is that the gradient of our tangent is going to be minus a half, because it's going to be the product of the two gradients has to be equal to minus 1. So we take negative the reciprocal of our gradient, and that gives us minus a half. Okay, so we have minus a half is going to be the gradient of our tangent. So that's good. So now we're almost done with this question, because we know the gradient of the tangent and we have a point on the line. And the two things that you need to find the equation of a line are a gradient and a point. And we've got both of those now. Okay, so what we do is we now sub in the point, which is minus 4 minus 8, and we sub in the gradient. Now, in year 11, we use the equation y equals mx plus c to do that. At A-level, there are other equations that you will use. But for GCSE, we're going to use y equals mx plus c. So we know the y is minus 8. We know our gradient is minus a half. And we know that our x value is minus 4. So minus 4 times by minus a half is going to be 2. So we've got minus 8 equals 2 plus c. So we take the 2 over the other side. So c is minus 10, which gives us the equation of the line as being y is equal to minus a half x minus 10. Okay, and that is that first question done. And in my very last question on the paper, a grade 9 question, and I know that in my experience, often year 11 students really struggle with that. So let's just quickly review the steps. What did we do? We subbed the point into the equation of the circle to find out what k was. Once we knew what k was, we found the gradient of the radius. We then took negative the reciprocal of that to find the gradient of the tangent. And then once we knew the gradient of the tangent, we subbed in the point P into y equals mx plus c, and that gave us the equation of the line. Okay, very good. Right, let's have a look at the next question. Right, a vector question. Now, I'm quite pleased with this particular vector question, because I know that certainly in Edexcel, in recent years, the vector questions have been, some of them have been really, really, really tricky. But this one, I think, is quite a nice, quite a fair vector question. So what does it say? It says the diagram shows a trapezium AOBC. AC is parallel to OB. So this line here is parallel. So these two lines are parallel to each other. Okay, that's fine. They also tell us that AC is 4 times OB, which is nice of them. That's good. O to A is A. Be careful. It's like going from there down to there, not that way up. So O to A is A and O to B is B. The point P lies on AB such that the ratio of A to P to B is 4 to 1. So this ratio of this side to this side is 4 to 1, which means that AP is 4/5, and it means that PB is 1/5. Okay, so that's what we've got. We've got 4/5 and 1/5 of the length of that line. And it says use a vector method to prove that OPC is a straight line. Now, if things in vector world, if things are a straight line, what we're going to try and prove is that these two vectors are parallel with each other and that they both share a point in common. So I'm going to try and find an expression for O to P first, and then I'm going to find an expression for P to C. And if we find out that this is a scalar multiple of this, that would mean that they're parallel, and we know that they would both share the point P, because it's in both of those vectors. So that's the approach that we're going to take for this particular vector question. So first of all, then, let's try and find an expression for going from O to P. So to go from O to P, we're going to go, first of all, to go from O to P, I'm going to go O to A down there, and then I'm going to go A to P up there. Okay, so I'm going to go O to A and A to P. O to A is just vector A, so that's vector A. And then we're going to go from there, we're going to go from A to B. Now, to go from, rather, A to P. And to go from A to P, it's going to be 4/5 of A to B. And A to B is equal to, we're going to go minus A add B. Okay, So we're going to do minus A add B. So we're going to say we've got A plus 4/5 of A to B. Okay. So there we go. What we're going to do now. Thank you, Cara, for your little comment there. I appreciate that. Cara, you know you're the first person to ever comment on any of my live streams ever, because this is my first live stream, Cara. So you're the number one commenter ever on a Guffick Tuition live stream, Cara. There you go. Okay, so basically we've got so far. Now all we've got to do now is expand our brackets. Okay, so when we expand this bracket, we get 4/5 B, and we're going to get minus 4/5 A. So we then collect like terms. So A, take away 4/5 is going to give us 1/5 A, and then we've just got 4/5 B. And what I've done is I've taken out the 1/5 as a common factor there. So we've got 1/5 times by A add 4B. So we're going to park that result. And that's our expression we found to go from O to P. Now I need to find an expression to go from P to C. Okay, so that's going to be the next thing. So what route am I going to go from P to C? I'm going to go P to A, and then I'm going to go A to C. So to go from P to A, I'm going to do minus 4/5 of A to B, because I'm going against the direction of going from A to B, and I'm doing 4/5 of it. So it's going to be minus 4/5 of whatever A to B is, and then I'm going to add A to C. Well, we know from previously that going from A to B is B minus A. So we've got minus 4/5 of B minus A, add 4B. So again, I'm going to expand the bracket. So minus 4/5 B, and a minus times a minus makes a plus. So plus 4/5 A. And then we've got add 4B. So we now collect like terms. So minus 4/5, add 4. When you work that out, that's 16/5. So that one add that one gives us 16/5. And then we've got 4/5. So we're almost there now. And I can see that I've got a common factor of 4/5 that could be taken out of these first two terms. So I'm going to take that common factor of 4/5 out. And this is really good now because I end up with A add 4B. And that is absolutely crucial. So what we've got now is we now know that this vector is 4 times this vector, because it is 4 times 1/5 A add 4B. So that means that these two vectors are parallel to each other. So this is perfect. So I can now write down that the vector P to C is 4 times O to P. So therefore they are parallel. You must write this down, by the way, in order to get all the marks. Okay. So we've got 4 times, so therefore they're parallel, and they both share a common point P. So as P is in both of them, that means that OPC is a straight line as required. And that's how you would use the vector method for question 20 there in that particular question. Excellent. Right, let's have a look at what's next. Again, this question, I think, a really nice question. Very, very common on GCSE papers, kind of like a standard kind of like grade 8/9 kind of topic. The thing that's the most tricky, in my opinion, about this is the way that it says here, notice this suitable degree of accuracy. A lot of students, in my experience in year 11, don't know what that means, okay? So this is a bounds question, and they've included this sentence, a suitable degree of accuracy. Now, whenever they write that down, what that means is you need to find an upper bound for Y, and you need to find a lower bound for Y. And then we're going to consider what we're going to do with that once we've done those two things, okay? So first of all, let's consider our upper and lower bounds. So D is given to 3 significant figures, okay? So therefore, our upper bound is going to be 11.35, and our lower bound is going to be 11.25. So we've got our upper and our lower bound for D. M is given to 2 significant figures, so the upper bound is 8.45, and the lower bound is 8.35. Now, when you're dividing 2 fractions by each other and you want to find an upper bound, you need to have the biggest thing in the numerator and the smallest thing in the denominator. Okay, so we're going to have the upper bound in the numerator and the lower bound in the denominator. So the upper bound for D is 11.35, so we want 11.35 squared in our upper bound, and our lower bound is 8.35 for the M. So we put that into our calculators, and that gives us, because this is a paper 3, a calculator paper, So that gives us 15.4278. So that's the result for the upper bound. Now let's find the lower bound. So when you want to find the lower bound, you need the smallest thing in the numerator and the largest thing in the denominator. So the lower bound for D was 11.25. The upper bound was 8.45 for M. And that gives us a lower bound for Y of 11.49. So we've now found the upper bound and the lower bound of what Y could possibly be. So this is the key bit now. This is where we consider this suitable degree of accuracy business. Okay, so let's imagine we were going to try and give this answer correct to 3 significant figures to start off with. So to 3 significant figures, we'd have 15.4 for our upper bound, and we would have 15.0 for our lower bound. And those 2 figures do not match each other. Okay, and that's the key. You've got to go to the greatest degree of accuracy that you possibly can, whereby the upper bound and lower bound match. Now, to 3 significant figures, they don't match. So that's no good. So let's reduce it then. Say, let's try then to 2 significant figures. Okay, well, if we take this to 2 significant figures, it's 15. And if we take this to 2 significant figures, it's also 15. So both the upper bound and the lower bound agree with each other when we're going to 2 significant figures. So therefore, that is our answer to the quote unquote suitable degree of accuracy. So the answer is going to be 15. And I can't emphasize how important that bit is about where it says this suitable degree of accuracy. And that's what you do. You find the upper bound and the lower bound, and you see what they agree with each other to. Okay, so that is that question. Right, next one. Oh, we got some graph transformations. Again, not very popular in my experience with year 11 students. A lot of students, it's not very popular with year 12 A-level, I can tell you. And it's not really until students get into like year 13 that they get much more confident with this kind of like graph transformations. So first of all, in this one, question 18, we've got y is equal to minus f of x. Okay, now the type of transformation that is it's a reflection. Okay, so the key word there is reflection. Don't say flipped or anything like that. It is reflection. And if you have to describe it, you must use that word to get the marks. So it's a reflection in the x-axis, and I've just sketched there. You can see it's just a mirror image of what was up there in the question. So that's part A done for, I think it's just 1 mark for that bit. Now, this next bit is super tricky, and I think a lot of people would not know what's going on with this. I'm sure most people wouldn't know what's going on with this, in fact. So it says the curve with the equation y equals 2x squared add 5x minus 3 is transformed to the curve t by a translation of vector 4, 0. Find the equation of the curve t. Now, I know a lot of people have no clue about this. So first of all, let's think about what does that transformation 4, 0, what does it represent? Well, it means that the curve is going to be translated 4 to the right. Okay, so it means the type of graph transformation we've got is this one. It is y equals f of x add a, and that is a translation by vector minus a 0. Okay, so what that means is if we had to write this down as a graph transformation, if we had to write that down as a graph transformation, we'd write it like this: y equals f of x minus 4. Okay, that's the tricky bit right there, and that's what I think people would struggle with. Okay, so it's going to be translated by minus 4, so minus 4, and that's where you've got that 4 from. Now, what on earth does that mean? Okay, now what that means is if we're translating a curve by x minus 4, it means that everywhere that in the original equation there was an x, it's going to be replaced by x minus 4 instead. Okay, so that's what we do. So we replace everywhere there was an x by x minus 4. Okay, so we're going to say x minus 4, x minus 4. Now that's squared, so we expand the bracket. So that gives us x squared minus 4x minus 4x, which goes to minus 8x, add 16. And then just expanding this bracket, we get 5x minus 20. Expand the bracket here again, 2x squared minus 16x plus 32, and then collect like terms. Okay, by 2x squared, that does nothing goes with that. Minus 16x plus 5x is minus 11x, and 32 minus 20 minus 3 is 9. And that is our final answer for that one. And I know that most year 11s would find that really, really tricky. Okay. So this graph transformation is f of x add a, and it means it's been translated by minus a0. So it means it must have been that in the bracket, and that's what you replace x by. And that's the key to that question. Quite tricky, that question 18. All right, I'm going to keep on going through a few more of these until I've got to sort of like about halfway through the paper-ish, until they start getting quite easy. So question 17, what have we got here? There are only, it says, 3 red sweets, 2 yellow sweets, and 4 green sweets in a bag. And it says Nicola takes at random 2 sweets from the bag. Work out the probability that the 2 sweets are not the same color. Yeah, so we have somebody saying, yeah, they think Finn is saying it's quite easy. I mean, I agree. I think this is mock set 7 from Edexcel, so it's pretty up to date, but these questions are not too bad at all, I don't think. In fact, this question is quite a nice one of its type. I've seen way harder ones than this, that's for sure. Right, let's have a look at this question and see what it's saying. So now, the first thing to note here is it says Nicola takes sweets from a bag. So it doesn't say that she puts them back in the bag. And you wouldn't expect that somebody takes sweets out of a bag and then puts them back in. So what the inference is that it is going to be conditional probability. Okay. So in other words, what I'm saying is that 9 is going to go down to 8. And very often in these questions, that's what they do. They won't tell you that it's conditional probability, but they'll expect you to work it out from the context of the question. And somebody doesn't normally take sweets out of a bag and put them back in. So again, if you've got a question where it's like a box of chocolates, or it's, let's say, for example, somebody's taking sandwiches off a shelf or drinks off a shelf, then it's going to be conditional probability, which means they're taking them and they're not putting them back. Okay. So that means we've got a tree diagram for dependent events. And this is quite a nice one. So if, for example, Nicola takes a red sweet, then when she reaches into the bag for the second time, there'll only be 2 reds, but there'll still be 8 sweets in the bag. This bit students often find a little bit difficult. So let me just talk you through the first branch. So if Nicola selects a red sweet, when she reaches into the bag the second time, there are now only 2 red sweets and there are only 8. But because Nicola didn't take a yellow sweet, there's still the same number that there was before. And because Nicola didn't take a green sweet, there are still the same number of green sweets that there were before, okay? So therefore, that's how you do that branch. That's the only one that's gone down by 1, and these are the same. We can check if this is right, by the way, because you think this one's tricky, Fishfin, okay? So these ones, believe me, I've seen way harder ones than this one. So these, we know it's right if all of these branches add up to make 8 out of 8, which they do. Okay. Now let's imagine Nicola takes a yellow sweet. So the yellow sweet would go down by 1 from 2/9 to 1/8. But there'd still be 3 red sweets and there'd still be 4 green sweets. And if this is right, it should add up to 8/8, which it does. So 4 add 3 add 1 is 8. And then finally, if Nicola selected a green sweet, we'd have 4 would go to 3, but there'd still be 2 yellow and there'd still be 3 red. And these would add up to make 8. Okay, now Ben's got a question. What if somebody takes a sweet out? Will the denominator go down by 1 for all of them? That's a great question, Ben. And here's the answer to your question, right? The way you've got to think of it is, this is when Nicola reaches into the bag here for the first time, right? There's 9 sweets in the bag, Ben, okay? So the 3 of them are red, 2 of them are 9, and 4 of them are green, okay? She takes out a sweet, and we presume she eats the sweet, okay? So this whole branch, Ben, this is like a whole parallel universe. You know, it's like in Back to the Future or something like that. There's all different realities that there could be. These are, every single branch here is like an alternative timeline, okay? So what we're saying here is, this is Nicola reaching into the bag, Ben, for the second time. And there are now only 8 sweets in the bag. So the denominator, Ben, has gone down to 8 for all of them. I hope that answers your question. Yeah. So if someone takes a sweet, it means that every single denominator goes down by 1, because this is when Nicola reaches in for sweet 2. Okay. This is sweet 1. And there are only 8 sweets in the bag now, Ben. Yeah. Does that make sense? It seems like it does make sense to you. You're welcome, Ben. Now, it says, let's think about this. So it says, work out the probability that the two sweets are not the same color. There's an easier way and a hard way to do this. The more difficult way is to work out every single combination where they're different, like to work out red, yellow, red, green, to work out yellow, red, to work out yellow, green, and so on. But the quicker way is to say that the answer must be 1, take away red, red, take away yellow, yellow, take away green, green. That's the faster way to do this, okay? So it's going to be 1, take away all of those. So let's have a look at that. So first of all, how do we work out red, red? Well, the probability, remember in probability, we times along the branches, okay? So 3 over 9 times 2 over 8 is going to be 6 over 72. And by the way, although you can simplify these, I like to leave that unsimplified, just because it kind of like makes life less complicated when you come to add all the fractions together. Because we could simplify that fraction, but let's just leave it with the 72 there, okay? So that's your red, red, okay, because it's red and red. When you hear that word and, you times. So we could have red, red, or, and when you hear the word or, you add, we could have yellow and yellow. And yellow and yellow is 2 over 9 times 1 over 8. Or we could have green and green, okay, which is going to be 4 over 9 times 3 over 8. So in order to work this question out, we're going to say the probability of Nicola selecting two sweets that are different colors or are not the same color is 1, take away red, red, take away yellow, yellow, take away green, green, okay? And red, red is 6 over 72, yellow, yellow is 2 over 72, and green, green is 12 over 72. So that gives us 52 over 72 is the probability that Nicola selects the sweets that are not the same, okay? Now, at this last stage, simplify the fraction. I've simplified it there down to 3 over 18 for that final step. Okay, quite a nice one, that one. I've seen, although, you know, it is a little bit tricky. I know you were saying that it is tricky, Fishfin, but I think that, yeah, I've seen worse ones. This one, now I know for a fact this one confuses people because people get kind of like confused about the base of the cone. But let's have a look at this question. I know that people find this one a little bit challenging. So it says the diagram shows a sector OACB of a circle with a center O and a radius of 12. The reflex angle AOB is 210 degrees. So that reflex angle is like this one here, going all the way around there in the middle. The diagram also shows a hollow cone with a vertex O. That vertex is just the fancy word for the pointy bit at the top. The curved surface of the cone is formed by joining OA to OB. So what you've got to imagine is this is the net of that cone. And if you get some glue and you stick glue along there from O to A and you stick glue along there from O to B and you connect them up, then basically you're gluing those two sides together to form a cone, okay? So you would imagine that here, there's the O and the A and B have come together there along this line here. So that's how this cone has been formed. And understanding that is the key to this question for sure. So what have we got to do? So I think the first thing would be to work out what is this distance in this sector round the outside going from A to B. So we want to know what's this arc length going round from A to B. In other words, over here on the diagram, going round there. Yeah. No, I agree with you. I think this kind of question is quite hard, definitely. So yeah, what we're going to do. So first of all, we've got to find the arc length. So that is 210 over 360 because it's a fraction of the circumference of a whole circle. Okay, because that's what fraction we've got of the whole circle is 210 over 360. Times by 2, times by pi, times by 12. 12 is a radius. So this is just theta over 360 times 2 pi r is the arc length. Okay, so that's the formula that we're using. Theta over 360 times by 2 pi r, okay? So we've got 210 over 360 times by 2 times by pi times by the radius, okay? And that gives us 14 pi. So that distance all the way around from there to there is 14 pi. Now, what that means is when we glue A and B together, it means that the whole circumference of this new circle is 14 pi, okay? So we can now use that to work out what is the radius of the base of this cone. We know that this distance now is 14 pi, and we know that the circumference of a circle is going to be 2 pi r. So I've written 2 pi r equals 14 pi. So we can cancel the pi out and we can divide by 2. So the radius is 7. So we found that the radius of the cone is 7. So that's perfect. The only thing we need to do now is we need to basically work out what the height of the cone is now. Okay. So we now need to work out what the height of the cone is. Now, notice that in this little triangle here, we've got a right angle here because the vertex is straight above the center of the circle. Okay, so O is immediately above. So that's a 90-degree angle. The question tells us the slant height here, OC, is 12. So now we can find out the height by using Pythagoras. Okay, so what we're going to say is that the hypotenuse squared, take away 7 squared, is going to equal h squared. So from that, we can basically now find out what the height is. Okay, so Fish says, can we write down pi as 3.14? That's a really good question. Now, so somebody's asking the question, can we just use pi as 3.14? Okay. Now, I would say no, don't. And I'll tell you why. Because notice that the question says, give your answer to 3 significant figures, right? So you always want to be working in your answer to at least one more significant figure than you give your answer. So do not use pi as 3.14 if the question says, give your answer to 3 significant figures. Definitely don't. You could use 3.141 or 3.1415 if you wanted. So a more accurate value of pi would be okay. But don't use 3 significant figures in the working if you've got to give your answer to 3 significant figures, because you might get a rounding error, if that makes sense. Yeah. Okay, that's good. I can see you get that now, Fishman. So we've got h is equal to 9.746. So now we're sorted because we now know the height of the cone and we know its radius. So the volume is therefore 1/3 pi r squared h, and they're being very kind to us and they've given the formula, which is super nice. Remember, if you're in IGCSE, you get given it anyway at the front of the paper. So we have 1/3 times by pi times by the radius times by h, radius squared times by h, and that gives us 500.093. The question says, however, give it to 3 significant figures. So therefore, it's going to be 500 to 3 significant figures. All right, quite a tricky question, that one, I think. And it's this idea about these 2 edges, OA and OB, being glued together along that side there to make this new circle. That, in my experience, is what people find tricky about that question. All right, we'll do just a few more. This one, maybe another, I don't know how many more I'm going to do. I'm going to go as far as 13. Okay, so I'm going to do up to 13 and then stop when I've get up to 13, because we'll have done all the trickiest questions on this paper then. This one's quite tricky. I don't think this one's particularly nice. So I hate anything to do with ratios. I tell you, I'm not a big fan, world's biggest fan of ratios. So it says Amir has X nuts and Y bolts in a box. Amir takes out 6 nuts and 6 bolts from the box, and the ratio of the number of nuts to bolts is now 1 to 2 when Amir takes those out. Okay, so Amir then takes out, yes, I know, Fishbin, I hate ratios too. Amir then takes out another 8 more nuts and 8 more bolts, and the ratio of nuts to bolts is now 2 to 5. Okay, so what I've done is, let's imagine that X, they tell us in the question that X is a number of nuts and Y is a number of bolts. So when Amir takes out 6 of the nuts and 6 of the bolts, the ratio is 1 to 2. Now, here's a handy trick. If you've got this ratio is the same as this ratio, you can say that that means that this divided by this equals that divided by that. And this, I think, is the key idea for this question, or at least it is in terms of how I've answered it. Okay, that's the key idea right there. So what we're saying is that that divided by that equals that divided by that. So we're just going to write that down, leave that. That's one equation, okay? When Amir takes out another 8 nuts and another 8 bolts, that means that Amir has now taken out 14 altogether. And the ratio has changed now to 2 to 5. So again, we're going to do that little trick saying that that divided by that equals that divided by that. And we've got a second expression now. So we've now got two equations with two unknowns, which we can solve these simultaneously. So what I've done is cross multiplied. Okay. So I've said that y minus 6 times 1 equals 2 times by x minus 6. So that's what I've done there. And then I've expanded the bracket and I've added the 6. So I've just got that equation by cross multiplying and expanding my brackets. Okay. Ben's got a question. Ben says, could you also write x minus 6 over a third and y minus 6 over 2/3? That's a good question. I guess 1/3 and 2. So Ben's question is, could you write that as like a third and could you write that as 2/3? I think technically, Ben, you could, because when you say that you're going to divide them, yeah, if Ben, in answer to your question, Ben's saying, could I write them like that? Okay. Well, when you divided them, Ben, you would have had 1/3 divided by 2/3, and 1/3 divided by 2/3 gives you a half. So technically, Ben, the answer to your question is you could do that. Okay. Now, the next step is we're going to cross multiply this one. Okay. So we're going to go y minus 14 times 2, x minus 14 times by 5. Okay. Then I'm going to expand my brackets. So I get 2y minus 28 and 5x minus 70. Okay. Yep. So Fishfin says that they got y as 54 and x as 30. You're right, Fishfin. That's the correct answer. Yeah. But what you've got to do is simplify your ratio at the end. So Fishfin, you are correct. But let me just give everyone else a chance to get caught up. So I've cross multiplied that one times that one times that one. So I now expand my bracket. So 2y minus 28 equals 5x minus 70. And then here's the key bit. I now sub in this equation into that equation there. So I replace the y with 2x minus 6 there. Okay, so I've now got an equation that is just in terms of x only. So expand my bracket. So I go 2 times 2 is 4, 2 times 6 is 12. And that collect like terms and get everything over one side. So take 4x off both sides and then add the 70 to the other side. And I get x is equal to 30, okay, which some of you in the stream have got that answer. So that's really good. Then we just take that and we sub that x equals 30 into this equation to find out what y is. And that gives you y is 54. So well done if you got to that. So the ratio of the number of nuts to bolts is 30 to 54. But be careful. Fishfin, if you'd have written down 54 to 30, you'd have dropped a mark, okay, because it's worth 5 marks and you would have done all that work and you would only have got 4 out of 5. So because it says find in its simplest form, you should simplify that ratio, okay? And there's a common factor of 6 here. So we can divide both sides by 6 to get a ratio of 5 to 9, okay? Fishfin saying, can we solve this without substituting x and y? I mean, yeah, I'm sure you could. I'm sure that there are probably several different ways to think of this question, Fishfin. You know, it could easily be done maybe with a different approach, but I just thought that finding these two equations with x and y and solving them simultaneously seemed to be the most sensible one for me. But I think that's quite a tricky question, that one. So we're going to do a couple more questions. This one's a bit horrible. I can't really think of a really easy way to describe how to do this one. I think this one's a bit unfair. Well, not unfair, but I mean, it's a bit tricky. So I suppose the only thing I can say that is like a way to break into this question is the denominator there is x squared minus y squared, okay? Which some of you will recognize. I mean, some teachers call that dots, don't they? Difference of two squares. Okay, so that something squared take away something squared is the difference of two squares. Okay, so what we need to do is we need to factorize that. Okay, so it's going to go to x minus y times x add y. Okay, so that's the difference of two squares. Now, because we factorize that using the difference of two squares, it means that if it's going to simplify, the numerator is either going to have an x minus y in it or an x add y in it. Okay, it must have one of those. But if you look at the expression in the numerator, there's no negatives at all. So it's not going to have that in the numerator. So it must be x add y times something equals this whole thing here. Okay. Now, I think there are kind of like various division techniques and so on that you could do. I'm not that familiar with them, to be honest. But if you just kind of look at it and think about inspection, what would this have to be to make this on the right-hand side? You would have to have x add 3. So it's not very nice. And I've done it by inspection, by figuring out it must be x add 3 to make it work. So let's just check. X times x is x squared. That works. X times 3 is 3x. That works. X times y is xy. That works. And y times 3 is 3y. That works as well. Okay. So x add 3. Yes. So Noah, it is x add 3, as you've correctly said there. That is x. That's the other bracket. So when we've simplified it, it goes to that. And now we can cancel this out. Now, sometimes people get confused about what we're allowed to cancel, what we're not allowed to cancel. When everything's times together, you can cancel things out. So it's okay to cancel that and that, okay? However, it's not okay. So that is the right answer, okay? That's the final answer there. Sometimes students wonder, but hang on a minute, Mr. Guffick, can't I cancel out the x's as well? Okay, so like this. So if I had that, couldn't I do, I'm going to put a huge cross by this just so we can show that this is illegal maths, okay? You could not do that. That would be highly illegal, okay? And the reason we can't do that is you can't cross them out when there's a plus or minus there, okay? So hopefully you get the idea there. Cross, 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 cross. No, you can't do that, okay? So it has to stay just as that as the final answer. But you can cross things out when they're times together in the numerator and denominator, okay? All right, perfect. Right, that's that one. I'm going to do maybe one more. This next question I'm going to do is the last one that I'm going to do on this paper. I think what I'll do is I will work through the rest of this paper and put it on a paper walkthrough, okay? So I'll do questions 12 to 1 as a walkthrough and add it on to the exam paper walkthroughs, okay? So well done, everyone, for sticking with us for this bit. Let's have a look at this last question that I'm going to look at in this live stream. So we've got question 13 here. So it says, A and B are the points on the circumference of a circle with a center O. BC is a tangent to the circle at B. Okay, so BC is a tangent. Right, fine. OAC is a straight line. Okay, we've got to find the size of the angle ACB. Find the size of the angle, CBA. So CBA, we've got to find this angle here. Right, so what's the way into this question? The first key for this question is that when you've got a tangent makes a 90-degree angle with a radius, okay? That's one of your circle facts that you need to remember. So that means this angle here is 90. So if that's 90 and that's 20, we can, and I've drawn in, by the way, this line here, OB. So we can now find this angle that I'm pointing to with a pencil, because it's going to be 180, take away 20, take away 90, okay? So 70 degrees is that angle there. Then we can use the fact that angles on a straight line add to 180. So this angle I'm pointing to here is, Ben says, in GCSE, do I have to give a reason for each step and by stating the circle theorem? Ben, that's a really good question, right? The answer to your question is no, not always. It depends on what they say in the question, Ben, okay? So in IGCSE, Ben, it's the same as GCSE. So here in this question, it says you must show all your working. Ben, notice it has not said you have to give a reason for your working. So in IGCSE and GCSE, it will say give a reason for your working. Okay, so if they expect you, if you've got to say what circle facts you're using, then it will say you must give a reason. It will state that in the question, Ben, okay? But when it doesn't say, then you don't need to give reasons. However, you do need to show your working. Okay, so you must show your working out. So angles on a straight line add to make 180. So it's going to be 180 take away 70. That is 110, this angle here. This is an isosceles triangle. So I'm going to do 180 take away 110 divided by 2 to get this angle here as being 35. And this angle here also is 35. Now I know that they're both 35. We've got it sorted because the angle that we're after is CBA, which is going to be 90, add that 35. So that is going to be 125. Okay. And that is the final answer for that one. Perfect. Well, what I'm going to do is I will record a video in the coming days on the remaining questions on this paper. Okay. And I'll put that on as a paper walkthrough. So there's a complete paper there. But I just thought with everyone's got mocks coming up, that it would be really useful to start at the grade 9 questions and work all the way through. If you kind of like only joined the live stream partway through, you could be able to watch the recording to see all the grade 9 questions at the end. But really well done, everyone there. And thanks for hanging on in there for the whole like 45 minutes. I hope that you found that useful. I have, quick plug, GCSE target grade 9 groups and GCSE target grade 7 groups, which you'd be very, very welcome to join us in. If you can find the details on my website, which are advertised on the YouTube channel, or just get in touch with me and I'll tell you how you could join us. But we've got students there that are working now at grade 9, and we've got students that are, targeting grade 7. So we've got 2 different groups, target grade 7 and target grade 9. And we have 1 lesson a week. And it's, pretty much like what we've been doing in the live stream, except we work through the questions together. But thanks, everyone. I hope that you found that to be useful. And good. I'm glad that you found that to be useful. Thank you, Ben, and thank you, Fishfin. That's really good to hear that you found it useful. And I'll be doing more of these in the future. Okay. But have a great rest of your day, everyone. And maybe I'll see you in a future live stream. Thanks a lot, everyone. Bye-bye.